Video we will solve a question on constrained optimization. The question is, a firm has a production function that is homogeneous of degree 1 given by Q is equal to 2 under root Lk, where Q denotes the output, L and K denotes the units of labor and capital employed. Unit price of labor is $4, unit price of capital is $16. Assuming that there is zero fixed cost, then the total cost, that is the long run cost of producing 10 units of output will be, we need to find out. So since we have to find out the cost here, that means this is a case of cost minimization problem. That means we want to minimize the cost. What is the cost? That is simply the price of labor times units of labor employed plus price of capital times units of capital employed. So we want to minimize this cost subject to the production constraint. What is the production constraint? That is 2 under root Lk should be equal to that we are supposed to produce 10 units. So we set this 2 L under root Lk equal to 10. Now how do we solve this? So let us use the tangency condition here. Okay, first order condition or tangency condition or first order condition for optimization requires that the marginal rate of technical substitution between labor and capital should be equal to price of labor upon price of capital. MRTS is, it is marginal product of labor upon marginal product of capital. It should be equal to price of labor upon price of capital. Price of labor is 4, price of capital is 16. What is MPL? MPL is simply the partial derivative of production function with respect to labor. Okay, so given this production function, its derivative with respect to L will be so we can rewrite it as Q is equal to 2 L to the power 1 upon 2 K to the power 1 upon 2. Okay, for the sake of simplicity, the derivative of this function with respect to L, so the exponent of L becomes coefficient. So we have 2 into 1 upon 2 L raised power. When we subtract 1 from the exponent, it becomes minus 1 upon 2. Then we have K raised power 1 upon 2. 2 and 2 gets cancelled. So we will get K raised power 1 upon 2 divided by L raised power 1 upon 2. This is marginal product of labor. Similarly, we need to find out the marginal product of capital. That is simply the partial derivative of production function with respect to capital this time. So this time we take the partials with respect to K. The exponent of K will become coefficient. So we have 2 into 1 upon 2. It will become coefficient. L raised power 1 upon 2 will remain same because we are taking partials with respect to K. Then K raised power, the exponent of K will become coefficient. So we have 1 upon 2 minus 1, again it comes out to be minus 1 upon 2. 2 and 2 gets cancelled, so MPK comes out to be, in this case, L raised power 1 upon 2 divided by K raised power. Transposing this to denominator, exponent sign will change. So what is then MRTS is equal to MPL upon MPK. Okay, so MPL upon MPK, in this case we write MPL comes out to be K raised power 1 upon 2 divided by L raised power 1 upon 2. To this we divide the MPK, that is L raised power 1 upon 2 divided by K raised power 1 upon 2. It should be equal to the price ratio. So 4 upon 16 is 1 upon 4. So we will have K raised power 1 upon 2 divided by L raised power 1 upon 2. Transposing this to numerator, it will get multiplied but reciprocated. It will become K raised power 1 upon 2 upon L raised power 1 upon 2 should be equal to 1 upon 4. Bases are same, we can add up the exponents here. So 1 upon 2 plus 1 upon 2 becomes 1. So we will get K and here we will get L. Again base is same, exponent added up is equal to 1 upon 4. Solving for K, K will be equal to, rather L will be equal to 4K here. Okay, cross multiplying, L will be equal to 4K. Now we plug the value of L is equal to 4K into the production constraint. Okay, that means twice in place of L we have 4K raised power 1 upon 2 times K raised power 1 upon 2 is equal to 10. So this becomes 2. So 4 raised power 1 upon 2, it becomes 2. So because we have under root 4 is equal to 2 here, so we will get 2, and we have k raised power 1 upon 2 times k raised power 1 upon 2 is equal to 10. So this becomes 2 2s are 4, and bases are same, exponents again added, so we will get 4 k is equal to 10, which implies k will be equal to 10 upon 4, which comes out to be 5 upon 2. This is the value of k. Okay, k is equal to 5 upon 2. Then what will be the value of L? Simply plug k is equal to 5 upon 2 into this function. So L will be equal to 4 into 5 upon 2. So 2 1s are 2 2s are 4. So L will be equal to 10. Okay. So the value of L comes out to be 10. Then what will be the total cost? Now we know that our cost is equal to, total cost will be equal to price of labor, that is being given us as 4, times units of labor, we calculated it as 10, plus price of capital is 16, times units of capital is 5 upon 2. So 4 10s are 40, here 2 1s are 2, 8s are 16, so 8 5s are 40 again. So total cost will be equal to 80 units. Okay. So in this case, the total cost of producing, rather the total long run cost of producing 10 units will be equal to 80. I hope I make myself clear in this video. Thank you.